So hi, so today the main topic is my journey of making my own, not my own, like personal, desktop database application. Actually, this is not really fully developed yet. I'm still working on it. I'm making the DB indexing algorithm. I implement the search and insertion part, but the deletion was really hard, so I'm refactoring again. The reason why I think I chose to make this stuff is because not just like database. I'm a front end engineer. Is because before I leave the my ex company, which is Tosec Securities, I asked for the feedback of how to be a better engineer, how to be best, and I asked this and I get feedback from the senior engineers from there, and they say most important part is that they actually computer science. They're or operating system and database or whatever stuff. The core computer science is just like cardio of the athlete. So you have to go deeper and you have to learn a bit. And I realized that I have to learn furthermore. And after I quit the store securities because I was contract software engineer, and the already it was the contract already finished, so I have to go back to my school. Um, but actually, after leaving this company, I didn't, I didn't go out for the some kind of like I didn't go club. I didn't go to other abroad to release my stress. I just sat in my room and I studied again computer architecture of it. And and this thing is among those kind of things. So this is kind of a journey to learn about computer science. So this is actually using Electron. That's the application. Electron is it's just like using Chromium for the rendering part, because um, because it's really kind of hard to making the desktop application using C or whatever language. But this one is kind of good because since it uses Chromium for the rendering part, so I can use Rect TSX code on here, so it's working really fine. So this is actually my this dummy UI. So you can just um, change the sidebar and you can just open it. And my plan is to first make the DB index algorithm and make some kind of like um, the node layout of it. After implement the core library indexing algorithm, I will just implement the other thing. So this part is really nice. The more important part is like the caching and the indexing algorithm part. So main part is so the goal is to, because also as an engineer, when I'm trying to store some kind of documents, the name is really inconsistent. It's really kind of tedious to go to some kind of like documents that I'll download and go to there and change the name, like with the slug or whatever syntax of it. And it was really nice. Well, I thought, and it was really kind of slow to find documents in my desktop. I was wondering, so why don't we make some kind of personal database for it? So renaming is really much simple and faster. So this is kind of really my thought of it, and I'm really implementing it. And while implementing database, uh, like deep index part, this is the core thing what I learned. First of all, I try to use the class-based object-oriented programming language, not language, also OP, and that leads some kind of boilerplate, not boilerplate, just like the dirty code. So I change the class into the function that I see the functions also you can use, um, you can make OOP using functions here. So every these functions is working pretty fine. So every insertion and the search working pretty fine because I already make implement the test code of it. The mistake I did is I I really don't know like making very pretty good test code. So I just make it, and it leads me to have more bad code because I didn't think about test code quality of it. So this test code is the code quality is actually garbage, so I have to refactor it. And another mistake that I did was, um, if the insertion and delete operation is kind of insertion and search operation is kind of easy. The most easiest part is search operation, and next is the insertion operation. But more hard thing was is extra delete operation, because if you look at the B tree, I'm just gonna show you the show you the new one. Not this part. Oh. The B tree indexing is really kind of hard, because example, your minimum degree actually, let's say 3, and your max key is gonna be 3 times 2 minus 1, let's say 2. 3 is too far, so 2 times 2 minus 1 is equals to the 3, so your max keys is the 3, so node can have the 3 keys of it. And next thing is minimum key is actually the minimum degree minus 1, so it's gonna be 1. So 3. No, this is gonna be more tedious, so let me just try to find here. Just let's just use this. I'm just gonna use this because it takes so much time to implement the bit tree using Obsidian page. Copy paste it. Yep. Here. I think you guys can see here. So the bit tree most hard part, the deletion part is, we say minimum degree is 1. So this node here, this part, only can have the keys that have more than 1. So if it's like 2, it's pretty fine. It doesn't break the rule of the bit tree. But if it's like less than 1, that's mean it's already unbalanced. We have to balance it. The other issue of deletion is, example, if you're trying to delete 38, this is not gonna be happen. So there's nothing to do with it. You just have to delete 38. It's pretty fine. There's no issue of it. But what if you wanna delete this 22? If you delete, let's say if you wanna delete, let's say your minimum degree is 3, like 2. Let's say your minimum degree is 2. So the keys, no, your max keys, let's say 2 of it. Actually, this bit tree is actually the max key. The min keys is actually 2. So let's say your min keys length is 2 because it's already 2. So, and if you're trying to delete 22, the problem is that it's already unbalanced. You have to borrow from the siblings. So that's kind of tricky one, because at the pointer you're pointing here. If you're pointing here, you only know your current node, which is 20 and 22. But you can get the value of your parent, which is 6, 18, 30, 40, 52. One other thing is that you have to get your siblings. In this right now, if you're, I'm sharing the screen, so you think you might think that, well, there's nothing issue of it, but in the real code, if you're trying to implement it, you don't know the real value of the siblings. So you cannot really you don't know real value from the siblings, because because the data is inconstant. So you don't know the value of it. So you just only know the parents of it. So you have to reference parents, and you let parents to select this whatever keys or not. You have to, I can borrow from the keys or not. Example, if I try to borrow from the left, and the left will be unbalanced, so you cannot really borrow from the left. So, and you can really borrow from the right. Since if you're trying to borrow from the right, you have to get the minimum most smallest value, because in the node, because I think it's called the successor of it. Yeah, I think this is a predecessor, but whatever. So if it's right, you have to get the most smallest value in that node, because if you're trying to go the fetch this 38, this really break the B3 rules because the 38 is here, but 38 has to be bigger than 30. But if it's because if it's on the left, it's called the small. So let's say the 32 is here, 31, 33, so it's 38. So you can just borrow from that here, right? 31. So if you're trying to borrow from 31, that's more kind of hard part, is it? Because if you're trying to borrow 31, if you just replace it, it's more issue of it because the 31 is actually smaller than 30. It's bigger than 30, but if you're trying to go left part of here, there's gonna be issue. It breaks the rule of the B3. So you have to you have to put 31 to the 30 and let 32 place here. So you have to think about this balance of it. And this case is only valid in the right part. It is valid because you're basically borrowing from the right. But let's say if it's borrowed from the left, it's really complete. It's kind of similar, but the data to borrow is different because the right part you have to get the smallest, but left part you have to get the biggest. So if it's biggest, you have to get from here and you have to send it back here. And that's kind of really hard part of the B3 because B3 deletion is because you have to think about the every case of the deletion part, and that's kind of really bothering. And if you don't really follow the code, if you don't make your code cleaner than before, that will make you to spend more months, for example 2 months, 3 months, because you have to write test code even the minimal syntax of it. For example, if you're trying to get the functions that gets the if the right, left, or right siblings are not really not cause under for if you're trying to evaluate. So that's gonna be really has to be capsulated into function shapes. You have to write the task code based on that. But if you don't, well, you end up like me spending almost 3 months to refactor code this kind of code, and you're never able to implement your own delete algorithm. So this is kind of really the thing what I learned. So this is it. Have a nice day. See you next time. Bye bye.